This is how to display your data in an appropriate table. What I've got on the screen at the moment is the data that I'll be putting into the table. We've got some length data, voltage, current. What we need to put into the table are length, voltage, current, and resistance. So you notice that resistance is not in this set of data. We will calculate it from the voltage and the current. We use those to calculate using V equals IR. Now, I've put next to the data the device that was used to take the measurements. For length, it was the meter rule, and digital meters were used for the voltage and the current. That's important because we need to display our data in the table with the correct precision. I have the length measurements here in centimetres, voltage in volts and current in amps, so those are pretty straightforward. Now the length measurement was the independent variable there, so we only have single measurements for the length, whereas for both for voltage and current we have pairs of data. So this is 0.2 and 0.21, then 0.29 and 0.28, so on. And also for current we've got 10.2, 10.4, 1.3, 1.3. So they come in pairs because they were repeated. I repeated them once, so I need to work out an average for voltage and current. Okay, so let's start by getting a table laid out. I need to have length, voltage, current and resistance in there. Because both voltage and current were repeated, they need 3 columns each. Length is going to go over on the left, but I just want to point out that I took the measurements in centimetres, so I've written those down, 20 centimetres, 30 centimetres and so on. But it's almost always advisable to write your measurements down in the SI unit. So even though I measured them in centimetres, I'm going to write them down in metres. Next to length, I will put in the voltage. Now because I need 3 columns for voltage, it's a lot neater and simpler to group those 3 columns together under one heading of voltage. So I'm going to have a 1, 2 and average. They're all underneath the main voltage header there, so these are separated from each other, but they're all under voltage, so that's how we do it. We're also going to do the same thing for current. On the end I have resistance in ohms. I haven't actually spaced out the current very well there. Hopefully I can fit my readings in. So now we'll start putting the data in. I indicated earlier that when you're putting your data in your table, you should use the correct precision, and that comes down to using the correct number of decimal places. Now if we use a meter rule has got a precision of plus or minus 1 millimetre. So I need to write all of my measurements to the nearest millimetre. How that's going to appear when I'm using meters as my unit is I need all my measurements to go down to 3 decimal places. That because 1 millimetre is plus or minus 0.0001 metre. These are the same thing. So I need 3 decimal places for all of my length measurements. So I'm going to have I started at 0.200. 20 centimetres is 0.200 when written in metres to 3 decimal places. Then 0.3. Put the voltage readings in now. Voltage and current were both taken with digital meters. These have got a precision of plus or minus 0.01 volt or plus or minus 0.01 amps. These are both SI units, so I'm not doing any conversions here. I'll just write my data down to 2dp for all of my data here in these two sets. Okay, so I'm going to fill the table out and then work out the averages. Now I need to work out the averages for each of these. You'll notice that the averages have the same number of decimal places as the raw data. These two are the same, and the same for these as well. Because the average is technically still part of the raw measurement data set, I haven't done any further calculations with it, so it should have the same decimal places as the initial raw measurement. Now, when it comes to working out resistance, resistance is voltage divided by the current. I need to use the set of voltage data that is closest to the true value. As far as I can tell, well, I've repeated and calculated the average, so I need to use the average voltage here, this column here, to go into my calculation, and this average for the current as well. These two are going to be used to work out the resistance, so you could say this is the average voltage divided by the average current. And those are the values that I'll use to calculate resistance. Whereas the average values needed to have the same decimal places, now I'm calculating something here. So calculated values, we need to carry forward the minimum SF. So we're looking at significant figures here rather than decimal places. Here, the current, this is 4SF here. The voltage here, this is 2SF. So I should have 2SF for the resistance when I've calculated it. So let's calculate that. Comes out as 0.020388. So I'm going to write that down to 2SF, 0.020. So it's actually 3 decimal places, but 2SF. And the next one is 0.22. I've got 3SF here. Here I have 2SF. So again, I want to carry forward the minimum significant figures. So it should be 2SF. So this is 0.22. Now you can see I've got inconsistent decimal places here. We've got 3dp on top and 2dp below. This is perfectly fine because, as I said, we're basing what we're doing here on the significant figures. Whereas in all of these we have consistent dp. We've got all 3dp for L, all of the V's have 2, all of the currents have 2dp. We're going to have a mixture for the resistance, and that's fine. And there we go, we now have a table. I've slightly annotated this, but you can see what is essential to keep in here. Just finish off with a few lines here. That's how you should present your data.